Our entire planet operates like an enormous, unpredictable battery, constantly charging and discharging immense energy. This colossal atmospheric power source fuels every dramatic weather event we observe across the globe. Understanding weather isn't just about predicting rain. It's about comprehending Earth's dynamic energy system. Think of our atmosphere as a vast, invisible storage unit, accumulating solar energy and potential. This atmospheric battery stores vast amounts of heat, moisture, and kinetic energy, awaiting release. Viewers should care because these powerful discharges profoundly impact human infrastructure and daily lives. From sudden hailstorms to devastating hurricanes, these events are expressions of stored energy imbalances. Every gust of wind and every clap of thunder signifies a release from this planetary energy reservoir. This continuous energy cycle drives global weather patterns, shaping climates and ecosystems worldwide. Without this atmospheric battery effect, Earth's surface temperatures would swing wildly and unpredictably. It acts as a crucial regulator, absorbing and redistributing the sun's powerful, incoming radiation efficiently. This complex system ensures a habitable environment, preventing extreme heat and cold in many regions. Ultimately, human civilization depends heavily on understanding and adapting to these massive energy exchanges. Recognizing the Earth's atmosphere as a battery fundamentally changes how we perceive everyday weather phenomena. It reveals the immense, hidden power constantly shaping our world right above our heads. The charging process begins with solar radiation, Earth's primary energy input, warming the surface unevenly. Different surfaces absorb sunlight differently. Dark oceans and land heat up more than reflective ice. This differential heating creates temperature gradients, acting as the voltage difference in our atmospheric battery. Warm air, less dense, rises, carrying vast amounts of thermal energy upwards through convection currents. As this warm, moist air ascends, it cools and water vapor condenses, releasing immense latent heat. This released latent heat fuels powerful storm systems, intensifying their updrafts and overall energy content.
But this initial charge isn't evenly distributed, leading to a crucial imbalance across the global system.
The distributed Earth's rotation obel, leading to a crucial system, known as the Coriolis effect, then begins steering these moving air masses into vast patterns. These massive air currents become like wires connecting different terminals of the atmospheric battery. Pressure differences also play a vital role, with high-pressure areas acting as charged regions. Low-pressure zones become discharge points, where air rushes in to equalize the atmospheric potential. Wait until you hear what comes next about how this energy truly manifests itself violently. Imagine a giant global circuit, where warm tropical air travels towards colder poles, carrying energy. This constant movement of air and moisture is essentially a continuous transfer of electrical potential. Thunderstorms, for instance, are vivid demonstrations of this battery's rapid, localized discharge cycle. Within a thundercloud, ice crystals and water droplets collide, generating significant static electrical charges. Positive charges collect at the top of the cloud, while negative charges accumulate near the bottom. This creates an enormous voltage difference, far exceeding typical household battery capacities by millions of volts. When this potential difference becomes too great, the atmosphere's insulation breaks down catastrophically, and then something unexpected happens, releasing energy in one of Earth's most spectacular ways. Lightning bolts, powerful arcs of electricity, discharge this accumulated energy, sometimes striking millions of times daily. A single lightning strike can carry gigawatts of power, enough to light up small cities momentarily. This electrical discharge generates incredible heat, hotter than the surface of the sun, creating thunder. Hurricanes represent another colossal discharge, drawing energy from warm ocean waters like a massive thermal battery. They continuously absorb latent heat from condensing water vapor, fueling their destructive rotational power. This continuous energy intake allows hurricanes to grow into monstrous, self-sustaining atmospheric engines for days. Tornadoes, though smaller, are violent localized discharges, rapidly releasing kinetic energy from sheer forces. These powerful weather events are not random occurrences, but predictable consequences of energy imbalances. Each phenomenon represents a unique way the atmospheric battery equalizes its stored potential energy. Scientists relentlessly study these complex discharge mechanisms, to better predict severe weather outbreaks. Understanding these intricate energy pathways helps us prepare for the natural battery's powerful output. The sheer scale of energy involved in global weather patterns truly boggles the human imagination. It's a perpetual motion machine driven by the sun, constantly charging and then releasing its power. This continuous energy exchange makes our planet a living, breathing, and sometimes furious entity. The implications of this planetary battery system are profound, affecting everything from agriculture to aviation. Farmers rely on predictable rainfall patterns, which are direct outputs of this vast atmospheric process.
However, extreme discharges, like droughts or floods, can devastate crops and entire food supplies.
Coastal communities constantly face the destructive potential of storm surges, another powerful battery discharge. Electrical grids, surprisingly, are incredibly vulnerable to these energy releases, especially from lightning strikes. Power lines can be overloaded or damaged, leading to widespread outages during severe weather events. Even personal devices with actual batteries are affected. Extreme temperatures can significantly degrade performance. Cold weather drastically reduces battery efficiency in electric vehicles, limiting their range and charging speed. Conversely, excessive heat can permanently damage internal battery components, shortening their overall lifespan dramatically. This connection highlights how the macro-scale atmospheric battery influences micro-scale human technologies. Understanding these impacts is crucial for designing resilient infrastructure and robust personal electronics. Architects now consider wind loads and flood risks, directly mitigating the forces of atmospheric discharge. Engineers develop better lightning protection systems, safeguarding buildings and critical power stations. Even space agencies must account for solar flares, another form of energy discharge affecting Earth's atmosphere. This constant interaction between Earth's energy battery and human endeavors shapes our technological advancements. Our future resilience depends heavily on predicting these powerful energy releases more accurately than ever before. The ongoing challenge is harnessing this knowledge to protect our world and leverage its immense power. Recognizing the Earth as a battery empowers us to better manage our interactions with natural forces. The Earth's atmosphere truly functions as a magnificent, dynamic battery, constantly storing and discharging colossal energy. These powerful, natural energy exchanges drive all weather patterns, profoundly influencing life across our planet. If you found this fascinating, subscribe for more incredible stories like this, and share your thoughts below.